Hi everybody, it's Kerrie here at the North East Autism Society and I'm joined with Tony.
Hello.
And Davey.
Hello.
From the Life Science Centre. And today we're going to be talking to you about solids, liquids and gases. So Tony, could you tell us a little bit more?
I thought we could have a look at some solids, liquids and gases, and then also look at some weird stuff that doesn't seem to fit in any of those categories. And then we'll do something we get to make and get nice and messy at the end as well.
Right.
So yeah, that's what I thought the plan was, if that's okay with you.
Sounds good.
Great. So I guess the first thing is trying to work out what actually are solids, liquids and gases. So all the different things around us, we try to put in one of those three categories. And there are two things we need to investigate to decide which category it goes in. The first one is whether the shape is fixed or variable. Can we change its shape? And that's without adding anything on or breaking pieces off, just can we change its shape? The second one is, can we change its volume? So that's the amount of space that something takes up, its volume. So is that fixed or is that variable? So here are some examples. This brick is a solid. Its particles are packed really tightly together. So even if I squeeze, I can't squish them into a smaller shape. Its volume is fixed. Its shape is fixed too. I can't change that either. Fixed shape, fixed volume, it's a solid. Whereas this liquid here, this water, has the particles packed tightly together still. So if I squeeze, I can't change the volume, it's fixed. But these particles can flow past each other. So I can change the shape when I pour it. It's gone from long and tall to wide and short. And finally, my balloon contains gas, it contains air, and the particles in the air that make up the air are moving around really quickly with lots of space between them. So I can squeeze that space between them to change the shape of the air, the balloon, and also I can change the volume, the amount of space it takes up. So gases have a variable volume and shape. I was wondering if you had anything around your houses that could perhaps be that you think is a solid. Is there anything near you that you think could be solid? Something that has a fixed shape and a fixed volume.
Oh, I think I'm just giving it a squeeze, Tony, and it's not changing the shape or the volume. I think this is a solid. So this is just a heart-shaped ornament that I got from Mexico, actually. And that, I think that's a solid because I can't squeeze it. Can't do anything with it. It's not changing.
Yeah, I think you're right. Seems like it's got a fixed shape. It always stays as a heart shape, and you can't make it any smaller, can you? So no. I think you're right. How about you, David? Have you found anything solid?
Well, I've got a coaster, kind of mat.
Ah.
And it's solid.
Yeah, you can't change its shape and you can't make it take up less space. So I think you're right. So what about something liquid? Have you found anything liquid around your house? Something where you can change the shape, perhaps by pouring it, but you
now
can't take up less
space. A bottle of soy sauce. I'm going to have to be really careful here because I've got a lovely white t-shirt on as well. But I think that this, if you can see that is a liquid, isn't it?
Yeah, I can see it. It goes from being in the bottle to a drop shape and then forms that long flat shape in the bottom of your glass.
That's a liquid.
Great.
Well, I've just got my juice that's on the table.
Yeah. Great. Okay, great.
If I drink some of it, there's less left.
There is less left, yeah. So normally with our solids, liquids and gases, we try not to add anything or take anything away. But when they are tasty, that is tricky to do.
Yeah.
Okay.
I've got one here though, and I'm not sure what it would fit into. Shall I show it you?
Yeah.
So this is toothpaste. So obviously it kind of feels like a liquid, but I'm just not sure about that one because it's a little bit solid as well. And
Yeah.
funny, I can squidge it actually.
So you can change the shape.
I can change the shape, and I can obviously change the volume of it. So
Well, in fact, the volume, I think, could be quite fixed, because if you could change the volume, when you push down on that pump, it wouldn't come out. It's because it can't take up less space that instead it shoots up out of the toothpaste bottle.
Right, I see.
Yeah, but you're right, it is a funny one because it doesn't flow like a liquid. You've got it just sitting on your finger. And in fact, toothpaste is a mixture of solids and liquids mixed together to make up the toothpaste. So we call that a colloid if it's a mixture of solids and liquids. Nice one. I like that strange one. Did you find anything strange around your house, David, that didn't seem to work?
Well, I was making myself a wee cup of tea this morning, and I put my sugar in it, and I thought to myself, I wonder what the sugar is. So I brought some sugar, because the sugar seems to move about and change shape, and it's just a bit unusual, really.
Yeah, so things that change shape, we think perhaps it's a liquid or a gas. But do you think sugar is a liquid or a gas?
No, it doesn't. It doesn't feel like it. It feels like, I suppose, like grit. It's like wee stones.
I think you've got on something there. It feels like little wee pieces, little tiny pieces. So each individual piece of sugar, each little grain, each little crystal is a solid. You can't squeeze that any smaller, and that won't pour or flow. But when you put lots of them together, they do behave in a more fluid way, a way that they can flow. So an excellent one there. I found this sponge, and I thought, well, a sponge surely is a solid thing. But then I realized I could make it take up less space. I could squeeze it, so its volume is changeable, it's variable, and I can change its shape as well. So I thought, hang on, if I can change its shape and its volume, it should be a gas.
Yep.
This doesn't seem
a gas.
That's not a gas.
But when I looked closely, inside you can see lots of little holes, and those holes have air inside them. So my sponge is actually a mixture of solid sponge and air, so there is a gas in there too, so that's why it behaves a bit strangely. So yeah, and I thought I found one more thing that was a bit strange around my house. I'm just going to get my little dish and show you here. I've got some brown sauce, okay, and what do you think? Solid, liquid, gas inside the bottle?
Liquid.
So a liquid should change shape, so we should be able to pour it out. Uh-oh. Now you might have found the same thing perhaps with ketchup as well.
Yes.
There's a little trick to getting the ketchup or this brown sauce out the bottle. Do you know what it is?
I think if you give it a little bang on the top, perhaps, Tony, a little bit of force.
Yeah, so if we give it some force, whoop, there we go. Then it comes out. So there are some things which are very strange indeed. They become more runny, more viscous if you add a force. So these are shear thinning fluids. So this is a shear thinning fluid. So if you stir it or hit it, squeeze it, it gets runnier. And I also thought of something that does the opposite. When you put the force on, it becomes more solid, more viscous, tougher. And it's one of my favorite things to play with. So I thought we could make some. So I think Kerrie has some things ready to make this too. You need a bowl and a spoon.
Right, I might have to, yeah, okay. Got my bowl.
And I'm gonna need some corn flour as well. Okay, so I'm gonna pour some corn flour into my bowl. There we go.
Do you need a lot of corn flour?
And then I'm going to add some water.
How much corn flour do you need, Tony?
Oh, it's up to you, really. I just poured quite a bit in out of my packet, so I think I must have poured in, maybe 100 grams, but that's because I like lots of slime. But you don't need that much.
Put about a quarter of a pack in, so.
Okay.
Right.
And then.
So do I pour it in? Okay.
Yep. So add your water a little bit at a time. So add a little bit and then give it a stir to mix everything together, because you don't want to add too much. You just, so if you put a little bit at a time, you should be able to get it mixed together. Now, how are you getting on, Kerrie?
Yeah, it's quite tough, isn't it, to stir at first? But I think I might have made this before, Tony, a few times in the nursery, you see. So I'm going to keep going with that. I'm just going to keep.
Yeah. Now it's
I hope
interesting.
I've got this right, because I've not got too much corn flour left. So.
Well, that's when it's always good to go slow and steady with the water, then not add too much at once. So I'm definitely starting to get something good and slimy here. And it's interesting you said it was hard to stir. And I mentioned that the thing I was trying to make was something that would be liquid, but would become more solid and more viscous if you put a pressure on. So if you stir, you're kind of increasing the pressure there. You're applying that force to it. So how's your slime coming on, Kerrie?
I think mine is nearly done, actually. I think that is the perfect consistency.
Right.
A little bit tough. Yeah, I think.
So it should pour and flow like this and look quite runny. But if you were to tap it, it feels really solid.
Now, Tony, could you add, because I've got a secret ingredient here, could you put in a little bit of food colouring?
Oh, you could. Then you could have a different colour slime.
I'll try that. Okay, so I've got some red. Ooh, that's unusual, Tony, because it stays on the top in a little, if you can see that, a little bubble.
Yeah, you'll need to use your spoon to mix it in. I think as well, if we'd done this earlier, we could have added the food colouring to the water as well. That sometimes makes it easier to stir it in too.
Well, we'll see what happens here. Okay, right. It's very messy, isn't it? It's a very messy activity.
It is. I've got my kitchen paper here ready to tidy up. Some people like to play with slime outside. Wow.
Now that is cool. As well, some of our young people really like glitter. So you could add some glitter, couldn't you, as well?
You could. Then it would be lovely and sparkly as well.
What do you think, Davey? What do you think of this?
I didn't think that's what would happen when you put corn flour and water together. I had no idea that happened.
And
when it's really cool. It's
honestly, Davey, you should try it at home and send us some pictures, because it's really unusual because it goes hard on your hands.
Right.
Like that, you see, that's hard now.
Right.
But then if you lift it up, it's a liquid and it all just...
Strange. And that's really because the corn flour powder that makes it up is made up of little particles that are really quite jagged. So they can flow past each other normally, but then if you push them together with some force, they get stuck on each other, and so they become more solid. So that's how it can behave nice and runny like a liquid, or hard like a solid as well.
The thing is now, though, who's going to tidy up? Because my kitchen table looks a little bit messy.
I've got quite a bit of mess here as well.
It's really nice, isn't it? Look at that. So, Davey, I think we'd like to see your photographs of you making slime. That would be cool. And all of our young people that see this video, if they could send in their videos or their photographs of them as well. And maybe if we have some different coloured slimes and maybe some glitter. But it'd be nice, wouldn't it, to see all the different variations. Well, that was a really good activity. I like that one. I like that one a lot. So I think we will end there because I think we need to tidy up, Tony. So Davey, if you send us your photographs of your slime, and all of our young people, if you can get involved. But remember, it's a very messy activity. We don't want parents contacting us about the mess, so do it with caution. So we'll see everybody next week then, Tony and Davey, for some more science fun. Okay.
Great.
Bye, everybody.
Bye. Goodbye.